Webcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's SANS webcast. Spamhaus DNS Firewall, sponsored by Security Zones. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Matt Stith, Product Manager for Spamhaus Technologies Response Policy Zones. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Matt.
Thank you very much, Carol. Good afternoon, good morning, and good evening to everybody who's attending today. As Carol already said, my name is Matthew Stith, and we're going to be talking about RPZ today. So, with a little bit of history here, Spamhaus built its reputation on building spam data. So we went out and we built a bunch of intelligence on trying to solve the spam problem for a lot of people out there that were having problems with spam coming into their inbox, and which in turn was causing problems for people's infrastructure. So we decided to build up these lists for people so they could use this to block email from coming into their system. So even today, 90% of the world's email is still spam. And we found that we're helping to stop this problem with our intelligence, with our block list. So we kind of looked at all of this data that we were having and saw that we had the opportunity to look at it from a DNS perspective. So when we look at protection of somebody's infrastructure, we kind of look at it as a multi-layered approach. So what you want to do is have multiple things in there. There's no silver bullet when you're looking at trying to protect your infrastructure. So we came up with the idea of a DNS RPZ feed that you could use to input into your DNS resolver. So for a quick overview, this is how a DNS resolution works if you don't have any type of response policy zone in place. So when you're looking at this graphic right here, you see the green check mark. So what that green check mark is that's the actual user. And what they're doing is they're making a query to the DNS resolver that then goes to the DNS root server, DNSCOM TLD, and then DNS example, and then sends that back. So what you see on the other side is they're actually accessing a known bad website. With the current way that a DNS resolver would work, this would just resolve, and they would go to this website, and it could be a phishing website, it could be a malware website, or anything that could cause issues with your user or with your workstation. So when you apply in Spamhaus's threat intelligence, what it will do is it will hit the DNS resolver, and the user will get a warning, more or less, that says this has been blocked, and there will be no resolution out to that bad site. So we stop that with at the DNS resolution standpoint, and that will save you time on your cycle, so you're not going to be querying all of these results. So we're gonna take a look at what Spamhaus offers for our response policy zones. So we've split these up into 5 different categories, and the first one I'm going to talk about here is actually the one that's at the end, which is our drop zone. Our drop zone has about 1,000 entries in it, sometimes a little bit more, sometimes a little bit less. But what that drop zone is for the worst of the worst. These are people that we have seen that are bad and have been bad for a very long time. So we have put these people in our list, and we more or less say, you're never going to want to route information to these people. This zone is something that we actually offer for free. We want to make sure that people are able to at least protect themselves with, no monetary benefit to us, but we just want to be able to protect people out there. So then you go and you look at the next category up here, which would be the standard. And this is by far our largest category of zones. This includes our DBL zone, which is the domain block list zone. And that includes domains that we've seen within spam messages or that we've seen within our passive DNS infrastructure. To be able to put these in here and just be able to let you block that information from coming into your network. Next is the bad name server zone, which it's a smaller zone because there's going to be less name servers than there's going to be domains that you're going to be blocking. And what we see from this is actually if somebody has a lot of domains that are listed on the DBL that happen to be at a specific number of name servers, we'll actually end up blocking those name servers, so they won't be able to resolve when they start adding in new zones. So we're not going to keep on continuing to add to that DBL zone, so we just lop them off with the bad name server zone. Then your next one here, next category, is the malware category. And you look at that and you see that you have the Botnet CC, which is Botnet Command and Control Zone. These are known botnets that we've identified on multiple networks that could be serving up all sorts of things. It could be trick bot, it could be a spam bot like it could be a spam bot, and anything else that is serving up malware or serving up ransomware, and we just insert those in there, and that's largely an IP-based zone. Then we have the malware zone, which are things that we've identified directly that are a identifiable malware. The next zone that you're looking at in here is the malware aggressive zone. That zone is a subset of the malware zone. The reason that we call it the aggressive zone is these are things that were either previously bad or look like they're going to be bad. So we kind of put that in this zone where there's a possibility that you could run into a false positive in this measure. So we recommend that it's one of these ones that you can use, but it's more or less where you want to put your security posture on everything. And then the last one in the malware category is the malware adware zone. And that's where you're seeing ads on websites, and it will actually block the resolution of those ads. The next category that we're looking at here is the abuse zone, the abuse zones. And you have the abuse legit zone, which is an actual legitimate website that we found that has been, was good for a while and then happened to get compromised. So we put that in there. It's not a very large zone because we want to make sure that whenever we're applying our threat intelligence to anything, that we are erring on the side of caution. We don't want to be blocking anybody who had a small problem and fixed it, or something that may look bad. We just don't want to end up blocking somebody that was actually legitimate and make the mistake on that side. So that's why we keep that zone a little bit smaller. The next one is the ad server zone, which is similar to the malware adware zone, but has other abused natures on it. So it's more or less ad servers would be blocking something that would be an ad that would be redirecting to our abused legit zone. And then the last one on here is our bogon zone. So bogon is a non-allocated IP space, and we put those in there whenever we see a spammer actually utilizing these bogon non-assigned IPs, and they're sending out information from there. So finally, our next category and final category is our SBL zone and our Tor exit node. So we kind of put this in here in our diverse is, one of the last things that you kind of want to add. So when you're looking at all of these zones in their totality, it's really where you want to put yourself in your security posture and what your policy is on your network. It's not like you want to add every single one of these zones and be able to just block everything. It may not work for you to be blocking Tor exit nodes. You may want to have some of your people that are doing security research be able to access this type of stuff. But it's really where you want to put yourself in your security posture, and that's really where you want to make that line of demarcation when you make a decision on what types of zones you would use. So once again, an overview here. This is our zones that we offer. So next, we're going to be talking about the policy triggers and actions that response policy zones offer. So the triggers here that you'll see is a Q name, which would be the domain name essentially, and this would be a domain that would be just included within an RPZ zone. Next is the client IP. So this would be the IP that is connecting to your DNS resolver. And what you can do there is, the reason that you would use client IP within a DNS RPZ would be to block, more or less wall garden somebody. So they try and access the resolver and they're actually blocked right at the resolution level. So more or less you can trigger that support call when you want to let somebody know that who's being unresponsive, let them know that there is an issue with their system. Next one is the IP, which is just an IP. So an IP that is being resolved to, or an IP that's trying to do some resolution. And next is your NSD name, which would be the name server domain name. And then finally is the NSIP, which would be the IP of a name server. And then finally you have on here the actions that can be taken. So do NX domain, which would be somebody would try to access a domain and you would just end up with a 404. Or what you can do with the NX domain is you can have it CNAME over to a landing page that would be within your own infrastructure that would show somebody, hey, you tried to access a website that could be known as phishing, could be known as malware, could have ransomware, and you have that on there so somebody knows that they actually clicked on a link or tried to resolve to something that was bad. Next one on here is no data. So you just actually they try and do some resolution and they get no response at all. The next one on here is pass-through. So what pass-through is more or less a way of whitelisting. It's something can be listed within the RPZ, and if you set that as pass-through, it will not take any action on it. It will just pass it through, and DNS will resolve as normal. And then the next one here is TCP only, which only lets somebody access via TCP. They can't do UDP when they're trying to access. The next is the drop, which would just drop all the data, drop it right on the floor, and you would get no resolution at all. And then finally is local data, which is similar to using the CNAME, and you would just get the local data from the action that would happen based on the trigger that was in there. So with that overview of everything, we're now going to talk about a case study that was actually done with security zones and in Spamhaus, and this was done with Rackspace. So Rackspace, after a few years of working with them and getting everything implemented with RPZ with the company, Rackspace implemented response policy zones company-wide throughout all of their global data centers, which would be in Chicago, Dallas, Washington D.C., Hong Kong, and Sydney. They implemented it over all 5 of those data centers, and also there's one in London. They implemented that to stop some of the problems that they were having, seeing botnets pop up within their networks. These were nodes that were trying to be a part of DDoSes. And what they wanted to do is they just wanted to curb this because they were receiving a lot of complaints from customers who were getting bandwidth overages, or they were having downtime due to needing to have their infrastructure shut down because of a problem that they were seeing with botnets. So they implemented this, and what you see right here is this is the total hits that they saw over a month, and the total RPZ hits at 275 million, 217,000 domains blocked, and almost 9,000 devices protected. Now, looking at these are just numbers more or less to anybody. So I really like what one of my colleagues used to say was more or less whenever you gave numbers and things like this, he was like, that's great, but show me the graph. So here's the graph. This is what happened when Rackspace implemented RPZ. So this information here is more or less, you see when we turned it on October 29th, and you just see it fall off of a cliff. And this is the outbound traffic. So what some people have asked before is, why didn't Rackspace see this type of traffic? If you're looking at the actual bandwidth that's being used and the actual queries that were actually happening going out of the network, it was relatively small compared to what the entire DNS infrastructure of Rackspace was doing. So it's kind of a blip on the radar. They're not really going to ever see it. With RPZ, they were able to see that, oh, this traffic just completely stopped. And they were able to go back to their customers and say, look, there's something wrong with your device. You need to fix this. They were able to help them and learn that, okay, this is a problem. We need to solve this. What you see also in the split of this graph is there's also some inbound traffic that was stopped as well. So they were actually able to see things that were being on their network that were infected, that were actually being used as command and controls that hadn't been identified yet, but Spamhaus was blocking things that were known bad sources from coming into their network. So basically, on the inbound and on the outbound, they were able to make some customer remediations, and also that stops you from having to worry about trips to the accounts receivable department, where an angry customer is going to be coming at you with a few $1,000 bill that they don't want to pay because it's not something that they did, but they got compromised. So they were able to solve a lot of problems by implementing RPZ. So the next thing on here is the policy hit count that happened. So what you see here at the top is actually our drop zone, which, as you saw previously, is a small zone. It's not a very large zone. So what this policy hit count is actually how many times there was a hit. But when you go and look down the rest of these, you know, you see the graph going down. But now when you look at this next graph here, you'll see that the domains blocked per policy, that drop list is under the botnet CC list. So what happened here is we'll go back to that policy hit count. You see that drop is up almost at 175 million. What the drop is doing is, since these are known bad sources, this is where a network isn't going to care about the problems that are actually happening on that network. So they're letting that bad source hit another network as many times as it wants. So it's not a lot of sources that are happening, but for every 100 that are on the drop list, they're making at least 10-fold hit counts because we're just blocking that much more. But when you look at it from the domains blocked per policy list, it's a little bit lower because you just don't have as much information in there. Where you see is the botnet CC zone is actually blocking more. So overall, Rackspace had a very successful experience with this. We actually ended up creating a customized list for the domain block list that Rackspace wanted to identify specific threats within their network, and we're able to build up this zone, and we were able to help them and serve that to them. So after this, you know, we're gonna take a look at a couple of RPZ blocking examples because it helps you to visualize a little bit what you would kind of see with RPZ. So the first one here, this is a phishing email, and for reference, all of this stuff that we're looking at here either was or is currently being blocked by our RPZ. So what we have in here is an Office 365 phishing email, and the Verify Now link on there actually goes to Microsoft-0nolne.cf. So Microsoft, I'm pretty sure that they don't have a large entity within Central Africa. That's what .cf is. And also, they aren't going to have a domain that's going to have a 0 in it in lieu of an O. So obviously a phishing email to somebody who has an educated eye. There may be some people out here who would look at this and be like, oh, this is legit. I'm going to go ahead and click on it. I'm going to verify my account. So what would happen to this person is they would go in, they would enter in their login information. They'd be like, yay, my account has been verified. I'm good to go. And then later on in the day, they try and go and log into their Office 365 account, and they see, sorry, trouble signing you in. That's because they've had their information stolen. The malicious party went in, they changed the password, and the person can't get in. So they've had their account stolen, and the malicious party is going to use it for the proliferation of their business. So they're going to be sending more phishing from an actual Office 365 account to try and even give themselves a little bit more legitimacy there in what they're trying to do. So it'll actually make them a little bit more successful. So, and then we're going to look at a couple more examples here. So this is an actual legitimate website. It's a photography website that, you know, you could see that if you were in the area and you were looking for somebody to do some photography for you, you would go to this website and you would see that okay, you know, I'm going to get my wedding photographed by this woman, and you'll go to that website. And then there's another one on here that is a clothing website. Again, a legitimate website. The thing that is in common with both of these is if you actually visit these websites, which anybody who's on the call right now, please don't visit the websites right now, because there's a possibility that this would happen. I'm not sure how many people have actually seen the screen live, but this is what happens when you're infected with ransomware. So pretty much what it's saying is, we've encrypted all of your files. Please go here and give us some sweet Bitcoin so we can take some of your money from you, and we'll give you your files back. So what I'm really trying to say from all of this is, these were all within RPZ, and these are things that we would actually block. So instead of seeing this ransomware web page, they would actually see an access denied. They wouldn't see any resolution there, and you wouldn't have to worry about customers coming to you or your employees coming to you and saying, guys, what am I supposed to do? Do I pay this ransom? Do we blow away our entire install? What do we do? And also, coming from the Office 365 way of things, you're not going to have to be trying to get that account back. You're not going to be having to go to the Office 365 support saying to them, you know, this is actually our account. Somebody changed the password in it. You know, how do we get it back? Type of thing. So it's not going to be something that you're going to save yourself time from being able to have to worry about these things. So with all of these examples and the case study, I wanted to go a little bit into actually how you implement RPZ. So what some people can say is that implementing RPZ is easy. However, I kind of steel myself to that, because I know that making changes to your DNS infrastructure is something that's very critical. So if you're going to be making these changes to your DNS infrastructure, be very careful with how you're doing it. So the first thing that we're going to look at on here is kind of the hardware requirements and a little bit about bind. So bind is the preferred option for RPZ right now. There are other DNS providers out there that do offer RPZ. There is Power DNS. We're actually working with them at Spamhaus to help them make their logging a little bit better. That's the piece that we're working on with them, because it's a little bit lacking for what we would want to be able to offer somebody, so we could help them in their support of RPZ. So with that said, your recursive DNS servers should have around 8 gigabytes of RAM, an 8-core processor, and actually be a physical server. We've found that there are some issues with performance when you have a virtualized server, and also what you can worry about with a virtualized server is that you're sharing an environment with other resources, and what could happen there is you could have a huddle go down, or you could have problems with your hypervisor that could cause problems, and you don't want your DNS infrastructure to be dependent on something like that. And finally, with your hardware is actually the software element. Upgrade yourself to the most recent version of Bind. And more or less why we say that is because the current distributions out there, so if you were actually on your Red Hat install or your Ubuntu install, and you do a yum update, or you do an apt-get, the actual repositories on there are usually out of date. They're a couple of versions behind. And the reason that we want somebody on the most recent version is Bind makes, or ISC makes, a bunch of changes to their resolver, and we've been working with them to get improvements made to RPZ, so it's more performant, and you're not going to have to run into some of the issues that would happen on the most the very first offerings of our RPZ with Bind. So that's why we recommend you go to the most recent version of Bind. So, and then the next thing that you want to do after you have your hardware and your most recent version of Bind installed, you want to implement logging. So in here I have a sample of what we would recommend somebody add in for setting up logging. The reason that logging is important is so you're able to actually see what's happening with RPZ. You're able to gather those statistics, bring them back to your company, and be able to show them, hey, this is why we're using this. This is why it's good for us to have on our system. And also, you can bring to your leadership, hey, these are the compromised systems on our network. We're able to find these compromised guys and be able to remediate them. And finally, you'll be able to troubleshoot problems that could happen on your network. So you're able to go through, find the problems, and be able to resolve them as quickly as you can possibly do. And you know, with this next thing, you want to create a local RPZ zone. The local RPZ zone is the very first priority zone. So when you are getting zones for RPZ, you want to put them in the order of the most egregious to the least egregious. So the very first one that you want to put up there is your local RPZ zone. The local RPZ zone would be used for whitelisting things. I would definitely recommend that somebody put their own infrastructure in there, because with Spamhaus, with our data as perfect as we try to be with everything, there's a possibility that we could find one of your IPs that's in your infrastructure that is compromised. You'll be able to find out about it by seeing that it's listed somewhere. However, we don't want you to be blocking something within your own infrastructure. So you'll want to have that whitelist in there. And the additional thing that you have in here is you're able to add in block lists. So you'll be able to block things that you may not want your customers or your employees going to. And this is more or less the policy that your company wants to have. If you want to try and block your employees from going to Facebook, you can add it into RPZ. I know that, you know, at companies that I've worked for in the past, there would be a riot if that would happen. But, you know, that's something that you can do. That's based on the policy that you want to have for your own company. And the final thing that you can do is you can set something up, as I was talking about the CNAME, and be able to redirect somebody over to something where you think something may be bad. So the next thing that we look at here is this is the actual creation of your local zone. Now you can name the local zone whatever you want to name it. So you have up here localhost.your.local.zone.name. So the your all the way to name is something that you can create and name it whatever you want to name. So what you have in here is a couple examples of things that have been whitelisted. So you have in here SANS.org, and you have an NC name, which means domain name, and then you have it as an RPZ pass-through. So that means anything from SANS.org will get a pass-through. You're not going to be blocking it. The same with the star.sans, which means anything that is a subdomain of SANS.org will be whitelisted. It will be passed through. You will not block it. And then we look at the two IPs here, and both of these IPs are actually the IPs for Spamhouse's drop zone. And we do recommend that somebody's put in the IPs that Spamhaus serves for RPZ into the whitelist, just in case something wonky happens and we actually end up blocking something. And then the last one looking on here is baddomain.com. It's just more or less adding them in as a block list, and you're able to block that. And that's something that you would add into your name. Next thing looking on here is just the configuration of the local RPZ and the slave RPZ. This all needs to be defined in your name configuration. So what you did very first is you added in the logging in the name comp, then you created the local RPZ, and now you're defining your zones. And this shows you the definition of your RPZ zone, and then as you want to make sure that you set that type as the master, and then the anything that you're pulling from Spamhaus or an external threat source would be a slave zone. And you'll see down there that we do have the masters, which are those IPs that we whitelisted within the local zone. Those are actually the IPs that we provide that somebody can pull the local information from. So, and then the final thing that you want to look at here is just the enabling of RPZ. So you enable RPZ within your zone, and you're set. You're good to go, and you'll actually be enforcing on your zone. One thing that I always ask people to do when they're going to be enabling RPZ is when you very first turn it on, make sure that you set everything from your external source as a policy RPZ-pass-through. What that will do is, regardless of what you have in the zone, it will do a pass-through. It will still log that information, but you won't get any enforcement. So what you'll see is you'll see what would have been rewritten by what zone, but there'll be no enforcement. We usually recommend that somebody do that for 10 to 14 days so you can see what it would actually end up blocking, to make sure that you're not going to be blocking anything that is mission critical to your infrastructure, and makes you more confident in going to your leadership saying, this is something that we need to do, this is something that we need to implement. So with all of that, want to talk about a little bit about security zones. So security zones is a platinum reseller of Spamhaus, and they're the group that helps us with our support of our customers. They do the technical support. They help us with the implementation. So security zones actually what we have on here is a 60-day free trial. We're actually going to extend that to a 90-day free trial. So anybody who is interested in using RPZ, it's something that we definitely recommend that you try it out. And at the minimum of things, you can go and sign up and just get the drop zone for free. But if you are interested in RPZ, we do suggest that you do reach out to the security zones folks. With that, I'm going to hand it back over to Carol so some questions can get answered, and I will go ahead and answer as best as I can. Carol.
All right, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for Matt, please enter it into the questions window now. Our first question is, total RPZ hits, dips into the engine or found bad entries?
I'm sorry, could you repeat that question?
Sure. Yeah, it came in about 20 minutes ago, and I'm reading it exactly as they've phrased it. So if you still don't quite get it, maybe they could resubmit it differently. But they wrote, total RPZ hits, dips into the engine or found bad entries?
That's found bad entries.
Okay. How can I tell how RPZ is working?
So you'll since the very first thing that we ask anybody to do is to turn on logging, you'll see the rewrites happening, and that's what we mean by hits. So when a rewrite happens, that more or less means that it's rewriting the DNS query. So that's how you'll know that that RPZ is working. So you'll be able to see that the log file is growing, and you'll be able to distill that data as you need.
All right, thanks. Someone asked if you could go back to, I think it's 2 slides. I'm not sure if they had a question about it or if they just wanted to see it. So if we could just leave it there for a moment, I guess, and they could gather whatever information they were looking for. Our next question is, any technical support installation guides?
Yes. So as I was talking with about security zones. So security zones is the reseller who helps us with our technical support. There are also people at Spamhaus who would be able to give technical support, and we do have installation guides that are both available at securityzones.net and at Spamhaus. So you can go to either one of those and be able to get that information.
All right, thanks. And it looks like I'm incorrect. Go back one more slide, please. Thanks.
Yeah, no problem.
Okay. You have a compliment. Someone says, this is fantastic. Thank you, SANS, Spamhaus et al. Okay. Who is currently using RPZ?
So there are a couple of companies out there. Of course, we talked about Rackspace that's using it. We also have Rochester Regional Healthcare that's using it. So it's a hospital, and I mean they're both using it within their internal infrastructure, and also they're using it on their wireless network. So they have an open wireless network, and they're able to apply some policy to that and be able to protect the people that are using the free wireless at the hospital, that maybe just while they're waiting for somebody to get out of surgery to protect them a little bit. And we also have a slew of universities that are using it. I'm unfortunately unable to mention specific names, but we have universities throughout the world that are using it. A handful that are in the UK, quite a few that are in the US, and a couple that are located on mainland Europe and within the Asia Pacific. We also have a couple of internet service providers, specifically Access for All is one that's using RPZ, and then we do have some relationships with government agencies, specifically state governments that are utilizing RPZ, and there's the New York, New Jersey Port Authority that's using it.
All right, thanks. How is it different than OpenDNS?
Okay, so OpenDNS is OpenDNS is a cloud solution. So with that, it's more or less you're giving away the control of your DNS. With our feeds with RPZ, it's actually something that we're feeding that into your own DNS infrastructure. We're not asking you to move your DNS over to another provider. We're actually asking you just to use your DNS and apply our threat intelligence to it. So essentially what we want to say with this is we're just giving you the data and letting you make the decision on it. With OpenDNS, you don't really have that decision because it's their data, they're controlling it. Yes, you can make some decisions on it, but you're not actually seeing the full breadth of what you're pulling in that circumstance.
All right, thanks. That's all the questions we've had. Oh, another one popped in. Do you have any technical papers or white papers that can further explain and help educate us about this DNS security problem and how your solution addresses it?
Yes, we can. We do have those, and that's actually, Carol, that's something that I could provide to you that you can include with this presentation. And it's something that's available on our website, but I'll go ahead and make sure that you get it so you're able to just put it within one centralized location so people can see it.
Okay, great. I'll wait to post the slide deck till maybe you could just add another slide in there into your presentation, and then we can put that all together on the SANS page. Will that work?
Absolutely, that will work. And,
okay.
and yes, thank you very much for that question there. Yeah, we are working on making more robust documentation for everything. So it makes it so much more easy for somebody to understand how to implement and where some of the gotcha moments are within your installation process. So that is also something that is evolving. So we do have information that we will definitely provide, but I would definitely recommend that anybody who is interested in it, keep an eye on Spamhaus and on security zones so you can see the updates that we're making to that documentation that'll make it a little bit easier for you to understand and also to pitch RPZ to your leadership.
Okay, great. We did have a few more questions come in. Would you mind going back to the Q&A slide? I'm sure the person has what they need now. Thanks. Okay, do you have an architecture diagram that I can present to management?
We can build one. It's not too much of an issue that we can show how where RPZ lives within a DNS infrastructure. We have something that is a little crude, but it's something that we can offer. And I would recommend whoever asked that question just reach out to the security zone folks, and we can provide that to you.
All right. How does one get a free trial?
So essentially, what you would do is you would go to securityzones.net, and you would be able to sign up for the trial there, or you can go to the Spamhaus website and sign up there as well.
All right, thanks. That looks like all the questions we have. Do you have anything more you'd like to share, Matt?
No, I think I'm good. I appreciate everybody who joined today and all of the questions. And as we continue to grow RPZ, it's something that I definitely recommend anybody on the call keep an eye on. And even if it's something that you're not going to be at the end using Spamhaus's feeds on, I think it's something that if you're using a DNS infrastructure, you really do want to apply some type of RPZ install there, just to be able to protect yourselves from some of the threats that you're seeing. When I go back and look at when you go back and think about that phishing email example, you can actually see that if you got reports of a phishing email, you can actually add that into your local RPZ right away, and you would stop any further infection from happening on your infrastructure. Because there are some people that don't click on links right away, and you're able to just get a little bit ahead of the curve, because in today's world we are so reactive in how we're trying to solve some of these security problems that we have. What we're trying to add here with our threat intelligence is an option where you can be proactive, and you're able to use a trusted third party like Spamhaus to stop some of these issues before they even start on your systems. So with all of that, again, thank you everybody who joined today. And if you do have any further questions or needs, please reach out to the folks at Security Zones. And I don't know if my information is available as well, but I can also be reached out to directly. And Carol, if that's something you need me to provide, I'll make sure that gets provided as well.
All right, thanks. We did have one more question come in. I'm sorry for all the stopping and starting here, but they asked, does this service affect zone signing in any way? And they followed up with DNSSEC zone signing.
Okay, so that's DNSSEC. So what will actually happen there is DNSSEC won't be applied to anything that is on RPZ. So what essentially happens there is, since there's no resolution that's happening, DNSSEC doesn't get applied. So what will happen there is bad domains will have no DNSSEC, and good domains will. So you're actually able to see a better infrastructure there of these are the good domains, these are the bad domains, because you'll see that DNSSEC is applied to things that are not being blocked by RPZ.
All right, thank you so much. Well, that concludes our webcast. Thank you so much, Matt, for your great presentation, and to Security Zones for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.